two places in more towards Pacifica in the Bay Area, near called Montera Mountain and Sweeney Ridge.
So a little bit of background on like the world. The Earth's crust is comprised of multiple tectonic plates that basically just hold up everything, and like we really need them. And today we'll be focusing on the West Coast, and it's more unique because it's split up of so many like different like specifically the West Coast. There's so many different like plates that are in one place, and there's different like ridges and things like that, and they're all called physiographic provinces. And so the fact that we're on like a place that has so much movement and so many different aspects of like the geological parts of the world that are all in since we're on such a complicated area, we get like a more unique area of rocks, and we call it the Franciscan Melange.
So to start, we're going to explain to you guys a little more about tectonic plates and how all these interesting geologic formations actually occur. There's a lot of tectonic plates that make up the entire Earth's crust, and they're all constantly moving in different directions and forming many different plate boundaries. There's three main types of plate boundaries. The first one is a convergent boundary. It occurs when two plates collide. The thinner plate will subduct, meaning slide under the thicker plate, and this will create what's called the subduction zone. There's usually a deep trench that happens there. Another type of plate boundary is a divergent boundary. It occurs when two plates separate from each other at a mid-ocean ridge. These mid-ocean ridges form when magma comes up from the mantle and creates new crusts in a mountain-like formation where the two plates are separating. The last type of plate boundary is a transform plate boundary when two plates slide past each other. We're actually standing on a plate on a transform boundary, and we will get to more about this in a few slides.
So Pangea. Pangea is another word for Pangea is the supercontinent, and over 2 million years ago, all the continents that are now separate were just one big continent. And if you look at continents, like a more proof of this is that like they pretty much perfectly fit together. And
so like around 200 million years ago, the tectonic plates that formed Pangea started to break apart, and this caused this whole ordeal, which is with the Farallon plate. Now the Farallon plate was in a very complicated situation with the North American plate. What happened was, as the Farallon plate moved towards the North American plate, a lot of it started to subduct under the North American plate. Now, as the Farallon plate was subducting, the mid-oceanic ridge on the opposite side of this plate kept moving closer to the edge of the North American plate.
As the Farallon plate subducted, the large mountains of the mid-ocean ridge could not subduct into North America, and the subduction zone turned into not just like, it's not like the fault zone isn't just one fault, it's like a collection of different faults that make up this large transform system, because it's a transform, like how we talked about on one of the past slides, how there's different interactions between two plates. This one is like a transform boundary, and it's made up of a bunch of different faults that make this area so unique in its geology.
Yeah, so as you can see here, this transform boundary started to form around 30 million years ago, and 30 million years ago, the mid-ocean ridge could not subduct. So as you can see here, this is kind of like the transformation of this of the San Andreas fault zone, where the Farallon plate subducts more and more and more, and then it turns into, as of now, a very complicated zone of faults that are all transformed. So more about this San Andreas fault zone. All these multiple faults, you can expect that there's going to be chunks of land that have kind of broken off the coastline and off the Farallon Plate that are sliding northward along the coastline. So if you have all of like the west coast of North America, there's large chunks of land that are sliding up this coastline.
Sweeney Ridge is in the middle. Sweeney Ridge is in the middle of multiple parallel faults that run through the west coast. And in this photo, you can kind of see, like, it's like a little hard to see. You can see the ridges that are like going along here. Okay. And sedimentary rocks, mainly greywacke, form a mountainous terrain full of ridges, valleys, and lakes, the Crystal Lakes specifically. And like a big, like what's considered a large, like, kind of the deciding factor that San Andreas Fault Zone is there and that like the Farallon Plate did exist is that the ridges are perfectly parallel to the coastline, which is where they would be if our theory was correct.
So more about greywacke. This that whole area that you just saw is almost entirely made of greywacke. Now greywacke is a sedimentary rock. It's a form of sandstone. It forms on the coastline or in large rivers by underwater landslides called turbidites. All these sediments fall and cement in layers, and that's how you can uniquely like identify sedimentary rocks like greywacke.
And so, since there are so many breaks and faults in the area that lies between Sweeney Ridge and Montara Mountain, at some point between these two locations, the majority of the rock changes from greywacke to granite, which is just more proof of the fault zone and that there are so many different faults.
Now this is a very interesting transition because granite is a continental rock that is also igneous, and greywacke found in Sweeney Ridge is formed in underwater landslides, and it's also sedimentary. So, like, how do these two rocks change so vastly in such like a short space? Well, Montara Mountain is actually is a chunk of granite that originated from the Sierra Nevadas. It broke off when the San Andreas Fault formed, and it has been moving northward up California's coast. Another way we know this is because the granite at Montara Mountain is very weathered. It's like crumbly and brown, and you can tell it's traveled a very long distance, hence from the Sierra Nevadas.
Some more information on granite is granite was formed Granite is 40 kilometers beneath Earth's surface, where it formed, and it's formed over hundreds of million years. And just igneous rocks, like the longer they take to be formed, is the larger the crystals are that make it up. And it's like another descriptive factor of granite that's important is that how pale the color is, and that's because it's very high in silica. And it's part of the continental crust because continental crust has to float, and that's why it floats because granite contains feldspar and mica, which are both very buoyant and light materials.
So, kind of in conclusion, California's coastline is a very like diverse and unique group of rocks that was drastically influenced by the San Andreas Fault Zone. So, thank you.